Have you ever looked at a photo from space? Maybe one taken from the International Space Station or during the Apollo moon missions? And noticed something strange? There's Earth. There's the moon. There are astronauts, rovers, satellites, even distant planets. But one thing seems to be missing. The stars. No twinkling dots scattered across the black sky. Just darkness. And it's kind of weird, right? Because we know the stars are out there. In fact, space should be the best place to see them. There's no atmosphere to blur or block the light. No clouds, no light pollution. Just you and the raw universe. So, where did all the stars go? This question has sparked confusion for decades. Some people even claim it's evidence that space photos, especially the ones from the moon landings, were faked. I mean, if you were really on the moon, surrounded by stars, wouldn't your camera pick them up? Actually, no. And the real reason is much simpler than any conspiracy. It's not a cover-up. It's not CGI. It's something far less mysterious and far more technical. It comes down to exposure settings, brightness, and how cameras work. Let's start with a basic idea. Every photo a mic, whether it's taken with a smartphone, a DSLR, or a space-grade camera, is a recording of light. A camera captures light using a sensor, and how that light is captured depends on 3 settings: aperture, ISO, and shutter speed. Together, they determine the exposure of the image, how bright or dark the photo ends up. Now think about standing on the surface of the moon. You might imagine the moon is a dark place, but it's not. The sun is blasting it with full, unfiltered sunlight. Much more intense than what we get on Earth because the moon has no atmosphere to scatter or absorb light. It's like standing under a giant spotlight. Everything around you is lit up with incredible brightness. The surface glows. The astronaut suits shine. The metal parts of the lander reflect blinding sunlight. To take a photo in that environment, one that doesn't just come out completely overexposed, the camera needs to use very short exposure times and a low ISO. That means it's letting in as little light as possible, just enough to properly expose the brightly lit subject, like the astronaut or the lunar module. But here's the thing about stars. They're really, really dim, especially compared to the sunlit surface of the moon. So if the camera is set up to capture bright objects, using fast shutter speeds and low sensitivity, it completely misses the faint starlight. The stars are still there, of course, but they're too dim to be picked up under those settings. They're effectively drowned out, like trying to spot a candle flame next to a stadium floodlight. It's the same reason you don't see stars in photos taken from the International Space Station during daytime, which, by the way, happens every 45 minutes as it orbits Earth. The sun is out. The Earth is glowing. The station is bathed in sunlight. The camera has to reduce the exposure to avoid blinding brightness. And in doing so, it filters out the faint stars in the background. Think about it this way. If you've ever tried to take a photo at night with your phone, you've probably noticed something similar. If you point your camera at a street lamp or a lit-up building, the stars in the background disappear, even though you can still see them with your eyes. The camera simply isn't set up to capture them in that shot. By the way, if you like this content, remember to subscribe and like. Let's continue with the video. Now, if you do want to photograph stars, you just need to change the settings. You need a longer exposure, a higher ISO, and ideally complete darkness around your camera. That's how astrophotographers capture those beautiful shots of the Milky Way or star trails across the night sky. They let the sensor soak in light over several seconds or even minutes, collecting the faint glow of stars that our eyes, and most cameras, miss in everyday conditions. And in fact, that's exactly what NASA and other space agencies do when they want to photograph the stars from space. Telescopes like Hubble, Webb, or the older Spitzer aren't trying to snap quick pictures of astronauts. They're built to do the opposite. To stare into darkness and pull in the tiniest traces of light across vast distances. That's why Hubble images show millions of stars and galaxies in astonishing detail. Those photos aren't just snapshots. They're usually long exposure composites, sometimes made from dozens or even hundreds of individual images, stitched together and processed to reveal the deepest parts of the universe. So, no, the stars haven't gone anywhere. They're not missing from space. They're just not always visible in photos taken under bright lighting conditions, using exposure settings that are optimized for something else. The confusion mostly comes from what we expect to see, and what we've gotten used to in art, movies, or science fiction. Think about space scenes in Hollywood. Directors love to fill the background with stars because it feels right. It makes the scene look dramatic, epic, cosmic. But those shots are artistic, not scientific. They're not bound by shutter speed or sensor sensitivity. Real photography, and especially in space, is limited by physics and optics. It's a balance between what you want to see and what you can afford to lose. So the next time you see a photo of an astronaut standing on the moon, or the Earth floating in space without a single star in the sky, don't worry. The stars are still there. The camera just wasn't looking for them. It's not a mystery. It's not a hoax. It's just how light works. And maybe that's even more fascinating than a conspiracy theory.